Hey, so in this video we want to create a relatively simple dust or sand effect. So just dust that kind of comes from the ground or is rolling, in the desert. It's just a nice effect and you will see why this is interesting once we have it. Maybe I'll show you a couple of references because often it's important to have references at hand for communication and also for, learning about what you're trying to do. And what this will mainly be about is how we handle different noises and how we can use them to emit points. So what we want to use here is for now just a simple plane because it's all about the concept and not so much about the environment. What's important here is that very often you would think that when you have dust, for example, then in reality, of course, this dust already exists. So you're really just moving stuff that already is there. Now, when you create effects, that doesn't have to be that accurate. It's totally fine to constantly emit new dust from a source, from the ground, because it will still look correct, especially if you have something like a texture that has fine detail in it that suggests that there is dust on the ground, on concrete, or if you have a sand texture itself, this will work as well. So we can directly work with just the grid, and what we need is just a pop network, of course, and we will just use the standard scatter function to scatter points right on this grid. If we keep working, it's a good idea to give us a bit of an idea what scale we're in. So let's use a Tommy as usual as a reference point, maybe move him a little bit to the side so that he's not too prominent, maybe something like this. And we can see it's roughly this kind of scale we're talking about. But to be fair, when it comes to sand, it's not really that important. You have a pretty wide range of variety when it comes to scale. It's often also a matter of taste. What it boils down to very often, though, is the size of the sand corns. So what I often do, and let's actually start before we talk about this, and as you can see here, we just emit new points. Let's make sure we turn real time on. And now you can see maybe we could increase that at some point, but for now, let's first make them move. And we move them just with a pop force. It's relatively straightforward. And we add some wind in the direction of, you can't see it, but it's negative Z. You can see it down here behind my head theoretically. So let's maybe add -3 or something, and then add some noise. And we can see where this is going. Let's make sure we also have a ground, because currently it goes through the ground, of course. So let's merge in, which we will instantly set to mutual, a ground plane. There you go. And now this will collide with the ground as well, which we can make invisible for now because it's enough that it's there. And you can see maybe we should increase the noise a little bit. There you go. The amplitude of the pop force. And you can already see this is kind of how sand behaves. It really just flies away in a more or less chaotic way. So let's make sure that this sand kind of disappears over time. So of course what we have to change is under birth our life expectancy, maybe 2 and 1, I have no idea. Let's give it a try. Yeah, something like that. And it basically suggests that the sand breaks up in a way that it's not visible anymore at some point. So this is not too bad. Maybe we can increase the amount of points. This is really just the base. One thing that I usually do, as you can see here, when I have more points, it becomes really dark. Since later on when you will render this, the size of each grain will guaranteed be much smaller. Let's press D and change the size of the point visualization in the viewport under geometry, and here under particles you can define how big the points should be. I wouldn't make it too small because then it's also not very realistic, but maybe something like 1.5 or maybe 2 is a good number to give a good impression of what it will feel like later when you render it. We will talk about this at the end. This is all about p-scale. Okay, so now that we have that, we can also change the background because then it's a bit easier to see what our dust is actually doing. And this is not too bad. You can already see that there is, coming from the pop force, a little bit of a structure on the ground. It feels like it's not, evenly emitted, but because it's born and instantly moved around, you can see those streams that are created. And we want to actually push that further because it's a very nice effect that gives a lot of detail and structure to it. And of course, you can always change the scale of your input. This is really just a small area we want to test in, and then we can expand it later on. So let's try this. And you can see fundamentally nothing changes. So you can expand this to a higher area. Like we said, we want to increase this kind of structure that we see. And here comes a new technique in, and that is when we emit new points, we cannot just emit evenly everywhere like with a scatter, but we could actually use, just like with a scatter, use an emission attribute that defines where the points come from. And what we can use for this is actually a noise, and it comes really handy in here as an emission attribute. Let's make sure we have enough subdivisions in our grid. Whoops. And there are multiple ways of doing this. There is actually since Houdini 18 an attribute noise node, which is pretty nice because it creates a color, and we can instantly change standard stuff like the type of noise, the size of the noise, and we can even make it animatable. In this case, the sparse convolution is not animatable, but other ones are. For example, the standard simplex noise is animatable, and here we can change, just like with the pop force, change the pulse duration. So when we press start, you can see this is actually moving. The only thing that bothers me a little bit about this is that it's a vector, it's colors. It's not necessarily a problem, you could use it anyway, it would just take the red channel, but let's turn this into a float, because then we have a black and white function. Now let's first try this and use it as our emitter attribute, and we can do this, like I said, here in pop source directly on the first tab, emission attribute, and this was actually I think it was mask, no, it's CD, of course, yes, CD. So we take CD, and we should already see a difference. Let's turn off the guide for a second. It's not that obvious, but actually there is a difference because the sourcing comes from, is based on this attribute, which is constantly changing. But as you can see, it's not that strong. So let's make it actually stronger. And for this, I would use a remap or a fit function to make sure that the contrast of our noise is stronger. We already seen that. If not, just check the noise video again. And let's actually change the noise type. I like the sparse convolution a bit more. Now we can't use the animate anymore, but we can use an offset, and we could just put in something like $T or something, and then it will move, which is totally fine. Maybe even good that it moves to the side. And maybe even -T, then we change the direction. You could even click on this, and then you have a vector version of this. So it's up to you. Now actually I decided to use Y, because then you can't actually see a direction anymore. So it looks like this, which might even be the better option. But how do we increase the contrast? There are ways of doing this in the noise node itself, but I'm not a big fan of it. I usually combine it with a remap node. If you've seen the fit function video, then you know how to do this. Attribute remap. Oops. What we want to increase the contrast for is the CD attribute. So we can now change the input and the input min and the input max and increase the contrast. And of course the idea is where it's black, there will be no emission and the whole thing is moving. Actually, if you don't like the speed, of course, you just change the expression in the attribute noise, obviously. And let's see what this gives us. And this is actually the interesting thing. And before we move on, let's actually quickly make sure that what comes out of our PopNet is, if you look here, maybe on the first frame you can see it better, is not only the points but also the ground plane. So let's make sure that we only filter out all the points with pop star. And now let's have a look at it again, maybe without the grid, and then you can see why this is pretty nice. Now we can really see that there is kind of a pattern moving on the ground, and this feels a little bit like the wind, which is not even over a certain distance. It's constantly changing and moving up different parts of our ground. Now, of course, you can make this nicer with different kind of noises and so on. That's up to you. But I want to quickly show you that you can use attribute noise with an attribute remap, but you can, of course, also do this with Vex if you want. So the logic here is that we create an attribute ourselves, float directly this time, and let's call it actually emit. And we fill this with a noise. And the noise, of course, is based on the position. This will give us something that we can't see. We could visualize it quickly. So we just go into the information window and then we click on emit, and then it's visualized. It gives us a visualizer down here for the emit attribute, and then we can see how it looks like. Now let's make it a bit bigger. So I divide the whole thing by 2, or actually even better, I put it on a parameter and call this size. And click on this button so that the parameter that I just created is also changeable. And this is not too bad. And let's make sure we animate this by adding an offset. The easiest would be just to directly put in plus time, which is time in Vex, and then the whole thing would just move. Not too bad, actually. But the contrast will be, again, a bit problematic. But let's try this first. Let's change the size to maybe 2, something like this. And then for this version, of course, we now created the attribute emit. So let's make sure that this works by changing the emission attribute from CD to emit. Rewind. And then it looks like this. And we can kind of see it. It's working. Otherwise, we wouldn't see any points. But again, we have a contrast issue. So let's make sure we increase the contrast. In Vex, we use the actual fit function for that. And it has 4 inputs, or the input minimum, then the input maximum, and we map this to 0 and 1. Because we know that out of this will come something between 0 and 1 anyway, and we want to change the contrast. So just like with the attribute remap, we do the same in Vex, maybe something like this, and everything that is blue will be 0. That's just our visualization. And then the effect will just be stronger and more visible when we look through the result. And here's one thing, because we are still having the visualization on. I thought for a second it might be CD, but then I checked, there is no CD attribute, and then I realized, oh yeah, it was my visualization that changed the color of my points. So let's turn this off. And now we can see that the noise is more visible again. Now, what else can we do? Let's actually do the last way of doing this, and that is we use a point VOP, because a VOP has the advantage of having nicer noise functions. So when I type in noise, I find unified noise, and I would always recommend either using unified noise or unified noise static. In this case, I use normal unified noise because that means I can promote the noise type. And of course, a noise is always controlled by the position. And what comes out of this, yeah, where does it go? It goes, let's say, into a new attribute that we used also with Vex. Let's call it emit. And we do this with a bind export. We call it emit. And that goes into, well, the output form of our noise goes into the emit. And of course, since we already know now what we have to do, let's already create our fit range to change the contrast later on. And now, since we're in VOPs, let's promote everything we might want to change. So we want to change the noise type, the frequency, so we promote this as well. We could maybe promote the fractal, and yeah, the offset if we want to animate the thing, which we will. And then in the fit function, the first 2 inputs, because we will want to change that. So let's see how this looks like. Let's make sure we visualize our emit attribute again. And now this looks pretty ugly, so let's quickly fix this. And this is, again, the reason why I'm not a massive fan of VOPs, because it needs so many steps to be usable. But again, we have to promote in VOPs so that the function doesn't have to recompile every single time. So now we can change the type of the function. We can change the frequency, maybe to something like that. We could animate the offset, because currently it's not animated. So the offset we can use the same way, $T. By the way, as soon as you use expressions, you will have to promote your parameter anyway. If you by accident try to use expressions inside of VOPs, it will not work. You have to promote the parameter, so just make it a habit. And now we can use our fit function here to change the contrast. Maybe again, let's change the frequency a little bit. And just for fun, let's try a different noise, maybe this one. Yeah, why not? And see how this looks like. Yeah, pretty much the same as the other ones, almost, maybe something like this. And again, the attribute we created is called emit. Let's put this into our PopNet. This will still work because we still had our emission attribute set to emit. Again, our points are now colorful because of the visualization. And now we have used WOPS to create the emission noise, which creates basically the same idea. One last thing maybe, if you still find it a bit too noisy, you could increase in the pop force the sharpness, so to say, of the underlying curl noise by lowering the roughness. And what you could also do is you could change the turbulence, because the roughness is basically, yeah, like the name suggests, how much detail you will find. And the turbulence is how often the noise will be overlaid over itself. So if I want this to be sharper, and what I mean by that you will see in a second, I usually change either the roughness or the turbulence by lowering it, or both. And then we should see that the form is a bit less chaotic, which didn't really work. I wonder why. Let's play around with this. Oh yeah, because the swirl size was actually too small. And here's what I wanted to achieve, and maybe you can see that. I can see now those waves. It's not just like completely random, but it feels like it's following certain paths. We talked about this before when we talked about the pop force. So yeah, small adjustments up to you. You know, let me change the life expectancy a little bit. But I think you see what I try to do here. It gives a very interesting shape, which might be too strong, you know, play around with it yourself. But you can see it's not just points that come from somewhere, but they come from somewhere with a certain shape. And this is actually something you will see in reality very often. And at the end of the day, at the very least, it will make your effect more interesting. And if you want to render this, keep in mind that the size of the points, of course, will be driven by the p-scale attribute. And this is something we will talk about in the next video. Now, as you've seen in the references, you can see that the sand felt a little bit more like smoke and not so much like particles. And the first thing is, it depends a little bit how close you are with the camera. You can increase the amount of points drastically if you want, and if you render them small enough with motion blur, which we will talk about in the next video, then it will still feel pretty realistic. But sometimes you actually will need to render them as volumes, and this is something we will talk about later in Pyro. So don't be discouraged that it doesn't look exactly like in the references for now. We will look at this technique in a later video, but for now I think it still makes sense to see how to use noise for the emission, because we will use the same even if we would render it as volumes. So for now, I hope this was helpful. Thanks very much and see you later. Cheers.